In this lecture video, we are going to take a look at formula mass, molecular mass, and molar mass, and we're also going to take a look at the importance of the chemical formula as well. Please read the OER textbook, chapter section 5.4, and the homework that associates with this chapter would be homework 5.4. The formula mass, molecular mass, and molar mass are going to be based off the chemical formula that we learned earlier. Pretty much the formula mass is going to be used for ionic compound because formula mass is derived from the word formula unit. Okay, so this one is going to be the chemical formula of ionic compound. Okay, so as you see, for example, potassium hydroxide is contain metal and non-metal. Right, so this would be an example of ionic compound. So whenever that we are talking about the formula unit and the formula mass is going to describe the mass of one formula unit, which means it's going to be the mass of this one compound right here. So therefore, in this case, what you are going to do is you are going to pretty much add off the mass of all the atoms that present within the compound together, and that would be the mass of the chemical formula of this compound. Okay, so molar mass is similar as well. However, molar mass is molar mass is similar to what we learned earlier for the each element, right? So each element, if you describe a mass of 1 mole, that's what the molar mass is going to describe here. So that means in this case, molar mass is going to describe mass of a mole, okay, of the molecule. Okay, so for example, in this case, if we have 1 mole of this molecule, right, that's going to be the mass of it. Okay, the molar mass that we are going to describe is can be used for both ionic compound and also molecular compound as well. Okay, so it's describe a mass of 1 mole. Okay, so it's used both in ionic compound and also molecular compounds. Okay, oops, sorry. And now let's take a look at molecular mass. Okay, so molecular mass, the name implies, right, is the mass of a molecule. It's going to come from the molecular formula that we actually determined in the previous video. Okay, so this is going to describe the mass of a molecule of the molecular compound. Okay, so that means in this case we are looking at the mass of a molecule here. We are looking at a mass of a compound. Okay, so therefore the unit of this will be different. When we talk about mass of an atom earlier, when we talk about atomic mass, right? Atomic mass, the mass of atom would be in AMU. The mass of a chemical formula unit would also be in AMU as well. And also the mass of one single molecule would also be in AMU. However, when we talk about a mass of a mole, 1 mole contains more than 1 molecule. 1 mole contains 6.022 times 1023 molecules. So therefore, in this case, the molar mass unit would be in grams per mole, which is similar to what we learned from the previous chapter when we talk about molar mass and mass of one atom. Okay, so that means in this case, the summary of this is that when we talk about formula unit, please know that your calculation have to be in AMU, and molar mass would be in grams per mole, and molecular mass would be in AMU. Okay, so this unit would describe different amount that we are looking at. In AMU, we are looking at only one single compound, right? In grams per mole, we are looking at a more like 6.022 times 1023 molecules of the sample, right? How many grams in that? And then when we talk about molecular mass, is the mass of one molecule. Okay, so these are different. Okay, so because we are looking at different amount of them. However, similar to the atomic mass that we learned earlier, the atomic mass of a single element have the identical value as in for the AMU and also in grams per mole as well. So if you recall from the previous chapters, we know that, for example, if you're looking at atomic mass of iron, right? So this is the mass of one atom of iron. That would be about like 55.8, I believe, AMU, right? And if you're looking at molar mass of iron, right, is going to come out to be the same value from the periodic table as well, but the unit would be different. The unit would be in grams per mole, right? Because this is the mass of 1 mole. This is the mass of 1 atom, so the unit would be different. So same thing here. So in this case, instead of talking only one element, we are talking about compounds, right? Because you have 2 or more elements come together in a fixed ratio, right? So these are the compound. Okay, so instead of looking at only just one element, we are looking at a combination of elements here. Okay, so let's take a look at how to calculate that. Okay, so pretty much you are going to add all the masses together from all the elements. Okay, so for example, this is come from potassium, right? Adding to oxygen, okay, adding to hydrogen, add all of this together, addition followed by the number of the least decimal places. So your final answer would come out to have 3 decimal places in unit of AMU, because this is the formula mass of ionic compound. Okay, so of this one ionic compound. Now, if you're looking at molar mass is the mass of 1 mole of this molecule, you are going to do the same thing. Okay, so you are going to account for all of those number of atoms within the chemical formula. This chemical formula right here contain 2 carbon, subscript 2 represent the number of carbon, subscript 6 after hydrogen is represent number of hydrogen, and then there is no number 1, you can just omit 1, right? So that's implied that there is 1 oxygen in this chemical formula. So in order to find out the mass, you are going to do the same thing. Obtain the mass of carbon from the periodic table, okay, multiply by 2 because we have 2 of them. Obtain the mass of hydrogen from the periodic table, multiply by 6, and then obtain the mass of the oxygen from the periodic table. Add all of these together, you are going to get the unit in grams per mole, because we are calculating the molar mass is the mass of 1 mole. Okay, so the most important one right here is that you are able to differentiate the amount that we are talking about, whether we are talking about a mole, mass of a mole, or we are talking about a mass of a molecule. Okay, so for the third one, if you want to find out the mass of a molecule, this is what it called molecular mass. As I mentioned earlier, it's derived from molecular formula from the previous calculation that I showed you, right? From the previous lecture video, that's how you can figure out the formula, the molecular formula. So pretty much in this case, it's the same thing. The mass of molecule would come from mass of each of those atoms within the molecule. Add those up together, you are going to get in the unit of AMU, because AMU is described the atomic mass unit of a molecule. Okay, so this is just one molecule, this is just one chemical unit, right? So again, I don't call ionic compound as molecule, because ionic compound are not described as a single simple molecule. They are present as the crystallized structure. We represent them as the simplest ratio as formula unit, right? So this is just describe a unit of ionic compound. This describe a molecule of molecular compound. This describe a mole of this compound right here, right? Molecular compound also. Okay, so we are going to use this concept in just a few minutes here, especially the molar mass, because molar mass, as you see, contain 2 units, grams and mole. So the molar mass will allow you to convert from grams to mole. So we're going to take a look at this as the conversion factor in just a few minutes here. But let's take a look at the importance of chemical formula first. Okay, so chemical formula not only tell us the mass of the molecule, it also tell us about the conversion factor or the ratio within the molecule as well. What do I mean by that, right? So for example, ethanol, right? So ethanol is the main component in drinking alcohol. So C2H6O, these tell us that when we talk about the chemical formula earlier, when we find out the molecular formula, you will need to find out mole to mole ratio of each element, right? So this is described the same thing. So those ratio, mole to mole ratio, is going to be our conversion factor that will allow us to convert from one type of atom to another type of atom, or one molecule to another type of atom. For example, in this case, if you're looking at this, right? So 1 mole of this, okay, would contain 2 mole of carbon, right? Because this is the ratio of it. So that would be the ratio that we can extract from here. Okay, same thing, you can look and compare between mole of the ethanol versus mole of hydrogen as well. This would be 1 mole of ethanol would require 6 mole of hydrogen, right? So according to the ratio here, same thing, you can do that with oxygen as well. It would be 1 to 1. Okay, within the same chemical formula, you can also compare between each of those elements as well. Okay, not just the whole molecule, you can look at each element as well. For example, we know that for ethanol, you see that in ethanol, 2 mole of carbon per every 6 mole of hydrogen, right? So this is the mole to mole ratio. You already did this calculation example in the previous lecture video when we are looking for the mole ratio for each of the element within the compound. Okay, so you can do the same thing for carbon and oxygen too, right? So it would be 2 to 1, and you can do for hydrogen and oxygen as well, would be 6 to 1, right? So pretty much this ratio right here would allow you to convert from one things to another. For example, the first one, right? This is going to allow you to convert from mole of ethanol to mole of carbon, right? If you choose this one, then it would be mole of hydrogen per mole of oxygen for this particular compound. Okay, so note that similar to what we learned in the first chapter 1.5, dimensional analysis, you can always flip this conversion factor depending on what you want to cancel, right? So if you want to cancel more of oxygen, then more of oxygen have to be on the bottom. If you want to cancel more of carbon, then more of carbon have to be on the bottom. So that way you can cancel those and then move forward, right? What do I mean by that? Okay, so this ratio that we are looking at is called stoichiometric ratio. Okay, so let's take a look at tie back into what we already know. Okay, so in chapter 2.2, when we talk about mole concept, you look at the grams and mole by looking molar mass of only one element, right? For example, if you're looking at iron, it's going to be grams of iron. You convert that to mole of iron by using its molar mass, right, in grams per mole. Okay, and you can also convert from mole to number of atoms of iron as well. That's what we learned in chapter 2.2 by using Avogadro's number, right? So there are this many atoms per mole. This lecture video is going to add more layer to that. So if you are making cake, it's more like a second layer of you making cake, right? You are making a little bit more complex here. So pretty much instead of talking about only one single atom, we are going to looking at compounds now. So we are going to add this stoichiometric ratio to be mole to mole. Okay, so that mole to mole that we see earlier right here, okay, is going to be the connection between the two type of element. Okay, so which is going to be this part right here. Okay, so this is the chemical formula ratio that we are going to take a look at. Okay, it allows us to convert from mole of something to mole of something else. For example, if you talk about ethanol previously that we're looking at, you can convert from mole of carbon to mole of oxygen, mole of carbon or hydrogen, oxygen or hydrogen, or you can look at mole of ethanol, which is the whole molecule, to mole of a specific element as well. So that means the ratio that we looked at earlier would allow us to do that. Okay, so that is the most important part right here. Without this ratio, you will not be able to find the connection between these two. Okay, and once you get into mole of different species, then you can do the same thing, right? You can use the molar mass of these to find out its mass, right? By using molar mass. And also, if you know more of these, you can also use Avogadro's number to find out the number of atoms of species B as well. So note that this atom here that we are talking about can also be replaced by molecule as well, depend on what you are talking about. Okay, so you can looking at, you have another option to use this as molecule as well. For example, if I give you the grams of C2H, 6O, this would be molecule, right? Because this is asking you for, this is giving you as molecule. If you need to find, let's say, only oxygen, then this will consider to be atom, right? So that would be atom because this is the molecule. So that means if you use Avogadro's number, the unit would come out to be in molecule per mole. If you're looking at only one single element, that would be an atom. Okay, so note that Avogadro's number can be replaced by any type of object, right? Because this many objects is in one mole. Okay, so it can be replaced by atoms, molecules. Okay. All right, so let's take a look at an example of calculation here. So if we want to know moles of ethanol that would contain 1.8 mole of carbon, what should we do, right? So pretty much start with what we know, okay? So start with what given. So in this case, we are going to use the ratio that we know, and we are going to start with this 1.8 mole of carbon that is given, okay? We are going from mole of carbon to mole of ethanol. So that means the conversion factor that we just derived earlier is have to connect between the two information. You need to have carbon and ethanol in that ratio. So pretty much the first one is what we are going to use, right? We are going to somehow use this to convert to mole of ethanol. So that means you can start with 1.8 mole of carbon, and we know that every 2 mole of carbon, right, is going to be in 1 mole of ethanol. So that means the ratio would be 1 to 2. You can see that the mole of the carbon will cancel out, right? So you are going to end up with mole of ethanol only. Okay, so that would be your final product right there. Okay, now let's take a look at number 3. Now it's get a little bit more complicated. It's adding more layers to it. Okay, so it's giving you grams of ethanol. Okay, so it's giving us grams of ethanol, asking us how many mole of oxygen. Okay, so it's giving us C2H6O grams. Okay, so it's asking for mole of oxygen. Okay, so what can we do? Well, we're gonna do the same thing, right? So pretty much, if you look at it here, right? So I'm going to use this roadmap that we used earlier. Okay, so we are given grams, and it's grams of ethanol, so C2H6O. Okay, so which way are we going? So in order to know whether you're going to convert to molecule or to atom or to grams, right, you need to know, or to mole, you need to know what the question asks. Okay, the question asks to find out mole of oxygen. Okay, so this is what the question asks to find out oxygen moles. Okay, so that means in this case, what you are going to do is, first you will need to convert these grams of ethanol to mole of ethanol first, right? Because this is mole of A. It have to be the same. This is grams of A. This have to be mole of A. So that means you are going to convert this to mole of ethanol first. Okay. After you get into mole of ethanol, are we going to find out atom of ethanol? Sorry, molecule, right? This is molecule. So I'm going to replace this with molecule. Are we going to find out number of molecule of ethanols? The answer is no, because the problem doesn't ask us, right? So don't do that. It's just waste your time. Okay, so that's how you're not going to be able to complete the exam on time, because you do extra step that is not required, right? So that means in this case, we are not going to this route because the problem doesn't ask to find out number of molecule. So keep going, right? So first step would be, first step would be convert from grams to mole. Okay, now we are stuck at mole of ethanol. How can we go to mole of a different species? So in this case, it's of oxygen. The answer is you will need mole to mole ratio, because the ratio here would allow you to convert from one type of species to another. Okay, so later on when you are seeing chemical reaction, you are going to see different type of molecule completely. This is what we are still talking about, the same molecule, but just different. We have a different focus on each atom within the molecule. Okay, so in this case, you are going to use this chemical ratio between ethanol and oxygen to convert to mole of oxygen. Okay, next, do we need to go to grams or atoms of oxygen? The answer is no, because asking for mole. So that means in this case, we're just going to stop right there, right? So that means after you get into mole of oxygen, that would be your final answer. So that means this would be the route that you will need to take. Okay, so the first step would be, again, start with finding out molar mass, right? Because if you look at it, right, so we need molar mass to convert from grams to mole. So therefore, we need to find out molar mass of ethanol. Add them together, like add all of these elements together. Molar mass is a mass of 1 mole. Therefore, the unit have to be in grams per mole, not AMU. Okay, do not write AMU here, because AMU will not allow to convert from grams to mole. Okay, AMU is just a mass of one single molecule. We don't care about one single molecule. We care about 6.022 times 1023 molecules, right, which is 1 mole. So that means the unit have to be in grams per mole. Okay. So once you know the molar mass, the next thing you will need to do is convert from grams to mole by using its molar mass. So because we want to cancel grams, so therefore in this case, gram have to be on the bottom and mole have to be on the top, right? So this mole right here would be on top. The number that go with grams always have to be the number of mass of, and then the number that go with mole would be 1, right? So this is the mass of 1 mole. Okay, so if you do this, you will be able to cancel grams. So what you're going to have left is mole of ethanol. We don't want that. We want to get more of oxygen. This is what you're going to do next, is converting by using mole ratio. We know that every 1 mole of ethanol contain 1 mole of oxygen. Therefore, if you cancel all the unit, you are going to get this many mole of oxygen as the answer. Sorry. So my expectation for you when you do the exam is that you are not going to just give me the final answer. You will need to show me of this unit cancellation process. Okay, without the unit cancellation process, you will not get any partial credit. Okay, so you will not get the full credit as well, even though you get the correct answer. Okay, so I need to see the unit cancellation. All right, so let's take a look at number 4. Okay, number 4 asks us what is the mass in grams of ethanol that contain these many grams of hydrogen atom, right? So let's take a look at the roadmap that we see earlier again. Okay, so pretty much what we know is start with grams again. Okay, so that means we're going to start right here. We're going to start with grams again, but instead of grams of ethanol, is actually giving us grams of hydrogen. Okay, so we know that we are going to start with grams of hydrogen. So that means the next, the first step would be convert grams to mole, right? It's always have to go through mole. So therefore, in this case, what you need to know is the molar mass of hydrogen. Okay, so we need to find our molar mass of hydrogen through the periodic table. Once you know molar mass, you should be able to find out mole of hydrogen. Okay, once you know mole of hydrogen, we are not going to go to atom of hydrogen because the problem did not ask us. So that means we can ignore this part. Okay, it asks us something else. It asks for grams of ethanol. So that means in this case, you are going to need to use chemical ratio between ethanol and hydrogen, right, in order to go to mole of ethanol. Okay. After you get to mole of ethanol, we're not going to stop here because the problem asks for grams. Therefore, we are not going to go through atoms or molecule in this case, right? Because ethanol is in molecule. Because the problem did not ask us to find out molecules. Okay, so we can ignore that. But it asks to find out grams. So therefore, in this case, you are going to again use the molar mass of ethanol to convert to grams. So that means the route that we are going to take to go from grams of hydrogen to grams of ethanol would be the top part right here, right? Convert grams to mole, mole to mole, and mole to grams again. Okay, by using different molar mass of different species and using the chemical ratio to connect those two species. Okay, so what do we mean by that? Okay, so I'm going to go ahead again, find out the molar mass of ethanol, which I already did, right? So add all of these elements all together. Okay, so this is grams of 1 mole of this. Okay, so the grams that you add is of 1 mole. Okay, so next, what you are going to do is you are going to use 33.7 grams of hydrogen that is given. And we are going to divide by grams per mole. My question is, can I use this number right here, which is the molar mass, right, that we just calculated? Can I use this since the unit is gram and mole? The answer is no, okay, because this number is the number of mass of ethanol. It's not mass of hydrogen. Therefore, you cannot use this. Okay, you cannot use this. So what should we do then? Well, you have to look at what is you want to convert exactly, right? You want to convert grams of hydrogen. Therefore, in this case, you will need to use the molar mass of just 1 mole of hydrogen. So if you're looking at the periodic table, that value is going to be 1.0079 per 1 mole. Wait. But I see 6 hydrogen here though. So why we are looking at only one, like this many grams? Should I multiply this gram by 6? The answer is no. Do not multiply that, because that is going to take into account when we talk about the ratio. Okay, so never multiply this by 6 because this is the grams of 1 mole. If you multiply by 6, then it's not going to be grams of 1 mole anymore. It's going to be grams of 6 mole, right? So in this case, whatever number that you obtain from the periodic table, note that it always have to be in grams per 1 mole. And it's going to be exactly from the periodic table. You don't need to multiply anything. The 6 number right here is going to be taken into account for the next step when you are actually converting mole of hydrogen to mole of ethanol. Okay, so in this case, we know that every 6 mole of ethanol, right, is going to equal to 1 mole of 6 mole of hydrogen is going to equal to 6 mole of ethanol. Okay, so again, never directly multiply these two because different meaning. You will not be able to cancel the unit. Okay, so the next thing what we do is that you are going to convert from mole of ethanol to grams of ethanol by using the ethanol molar mass. Okay, so now if you're looking at it, right, so you are going to be able to cancel off this. Okay, the most important thing here is when you are writing out grams, please always include the species afterward. So that way you know exactly what you can cancel and what you cannot cancel, right? So for example, in this case, we can cancel them because it's the grams of the same species, it's the mole of the same species. Okay, so when you are talking about mole or grams, make sure that you specify what species you are talking about. 3 sig fig right here, right, the smallest, this is multiplication and division. So therefore, these number 1 and 6, these two are called exact number, right? So in 1 mole of these, there are exactly 6 mole of hydrogen, right? So it's the exact number. So this will not limit your answer of the significant figures. So your answer come out to be 257. The answer is in grams of ethanol. So that means if you have this many grams of ethanol, you are going to end up having these many grams of hydrogen present in the chemical formula. Okay, so that's what it means here. The next example that we are going to take a look at is going to be the integrated problem that integrate the density concept to the mole to mole concept as well. Okay, so let's take a look at example 5. Butane is a liquid fuel used in lighter. How many grams of carbon are in a lighter containing 6.45 milliliter of butane? And it's giving us the density of liquid butane, which is in grams per milliliter. Okay, so that means in this case, you are going to have to rely on the dimensional analysis that we learned earlier, right? So you somehow need to get a certain unit in order to convert to mole-to-mole ratio and eventually convert to grams of a different species. So same thing here. We are going to use this roadmap still, but there is the step that you are going to take prior to taking this roadmap. Okay, so pretty much if you're looking at the stoichiometric ratio roadmap here, you will see that we're always going to start from grams, right? Either start from grams or atoms or start from mole, but never we can start from milliliter. So now that means we need to somehow take the pre-step first in order to convert this milliliter in order for us to be able to plug in any of this spot. Right, so if you're looking at this spot as the destination, so those are the one that we are going to eventually want to end up at, right? So if you're looking at this, if you're looking at what's given, it's given as volume, right? So it's giving us volume, which is in milliliter, okay? And it's also giving us the density as well. The unit of this is in grams per milliliter, okay? Note that ml is not mole. Okay, so don't confuse that ml is milliliter, which is describe the volume. So if you're looking at the unit of these, you will see that the unit of these are connected by each other, right? So you have milliliter, you also have milliliter here too. So that means these two describe the same thing, right? It's describe the volume. So that means somehow you can use these two information to help us to get into grams, right? According to the density, you eventually be able to find out grams through that. Right, because you have milliliter that can cancel out eventually, it's gonna give you grams. What do you do next then? Okay, so this gram is described grams of the butane. So therefore, in this case, what you are going to see is you're gonna start right here, right, which is the grams of butane that you are going to start with, right? So this would be grams of butane. Okay. it's asking for grams of carbon. Okay, butane and carbon is not the same. Carbon is the element present in butane molecule. So therefore, in this case, if you want to know grams of butane, if you is given grams of butane, you need to find grams of carbon. Therefore, you will need to find out grams of carbon all the way here, right? Because you are looking at two different species, right? A and B are different species. So that means what you are going to do is you are going to take the first route, right? So pretty much you are going to convert the volume to grams first to mass, and use that mass to convert to the mass of another species. Okay, so that means the process is still the same, except we're going to add one more layer of the concept that we learned in chapter 1.5, right, which is the density, to as the pre-step before you actually take this route. Okay, so what do we mean by that? Okay, so pretty much because we know that we're going to convert from grams to mole, you always need to find out molar mass. Molar mass of butane can be obtained from the periodic table. 4 carbons add to 10 hydrogen, add all together. That would be the mass in grams of 1 mole of butane. Okay, so what you are going to do is you're going to start with the number that contain 1 unit. Okay, because this number that contain 1 unit, eventually we don't want this unit anyways, right? So that's why I start with this, gonna be easiest for me. And I don't have to like flip these two because I would know exactly what I need to cancel. When you start with milliliter, we know that milliliter have to be on the bottom in order for these two to cancel out. Therefore, the grams have to be on top. And the information that allow us to convert from milliliter to grams, that would be the density, right? Because density contain grams and milliliter unit. Okay, so I would just add those two. Okay, so if you multiply these two, you are going to be able to cancel milliliter. You're going to have grams of butane left. That's exactly what we want, because if you're looking at the map here, that's what we want, right? We want grams of butane in order to find out mole, and using mole to mole ratio to find out grams later. Okay, so that means the next thing we are going to do is, since we have grams of butane already, the next thing is go through the mole, right? So you are going to convert from grams of butane to mole of butane by using its molar mass. Okay, so grams of butane can cancel out. Remember, this one is, I'm talking about butane, so that's why I'm keeping a reminder by writing the chemical formula above it, so that way I know exactly for sure this is grams of butane, is not grams of something else, okay, per mole. The next thing is, if you are stopping at this step here, you are going to get mole of butane, but that's not what the problem asks, right? The problem asks for grams of carbon. Therefore, in order to convert from this mole of butane, you will need to use the ratio between butane and carbon. I want to cancel mole of butane. Mole of butane have to be on the bottom. I want grams of carbon, so the mole of carbon have to be on the bottom, on the top. Okay, so that way we can convert mole to grams later, right? So every 1 mole of carbon would weigh about 12 grams of carbon. Again, I remind myself by writing out what species that it belongs to, right? So that way eventually I can cancel off this. Okay, so again, the molar mass of carbon, grams per mole, can be obtained from the periodic table. Okay, so do not multiply anything to it, right? So this is grams per mole from the periodic table. If you cancel the unit, you are going to obtain 3.20. Okay, so the this number right here, 3 sig fig, right, would limit, or this one, right? So these are the 3 sig fig that can limit the final answer. Okay, so that means on your exam, expect that I will pull out some dimensional analysis from the previous chapter that you already learned, okay, because it's the same concept, right? It's pretty much the unit cancellation. So pretty much that eventually you need to be able to get to grams, okay? So in order to convert from grams to mole ratio, and also to another grams as well, so you will need to be able to actually use the density concept to help you to do that. Okay, so pretty much this is rely on the unit cancellation. Now, what if you want to show me step by step instead of write it off this out? Can I do that? The answer is yes, you should be able to show me each step as well. Okay, so on the exam, if you are comfortable with showing me all the steps together, right, with the unit cancellation like this, right? So if you want to cancel the unit, you can, right? So all of this unit would cancel. You are welcome to do this. Or if you are not really like don't understand how all of these tie together and it's easier for you to understand like step by step, you are welcome to write this out step by step as well. For example, step 1, right, you are converting from milliliter to grams, right, and then you just include only this step for me, right, and get the answer. This would be step 1. And then after you get the answer for step 1, then you convert to mole. That would be your step 2. And then you use the mole of butane to convert to mole of carbon. That would be step 3. And then you use the mole of carbon to convert to grams of carbon. That would be step 4. You can show me each individual of this step, but on the exam as well. So instead of like combine them all in one step, you can actually break them down as 4 different steps. That is okay with me as well. Both of them are identical, so those would be if you set up correctly, those method would be full point for those. Okay. All right, so pretty much in this lecture, the most important part that you will need to practice again is going to come from practice. Okay, so by watching video, you will not understand how to do this, and you will not be able to do on the exam as well. You need to practice in order to do it well and do it fast on the exam. You need to have that skill. Okay, so note that so far what you are seeing is convert from grams to mole, and to another grams, right? On the exam, you might have to convert from grams to mole, and to atoms as well, because it's still on this roadmap here. So the DIY problem will allow you to practice some of these. Okay, so and also the Newton homework will allow you to convert from grams to mole to atoms, and mole to like molecule or something like that too. So just know that if you talk about number of atoms or molecule, always use Avogadro's number. If you talk about mass and mole, use molar mass. Okay, so that's what you need to know. All right, so pretty much what I would like you to do is I would like you to start working on the DIY problem to evaluate your understanding of this lecture video. Okay, so if you can do all of this and get it right, I mean, you pretty much pretty good on this concept. Okay, so that's how you evaluate yourself. The answer of these number problem would be posted on Moodle under chapter 5. Okay, so start doing this and check your answer. Not only the answer, you need to check the process as well. Okay, so make sure that you set up similar to how I set up in terms of unit cancellation. You need to show me how the unit cancels. Okay, so before we finish up this video, I would like to show the last example, which is this example right here, asking for number of molecules. Okay, so before, the example that you see is just convert from grams to mole, mole to grams, right? So now we're gonna look at conversion from grams to molecules. Okay, so in this case, you are going to do the same thing, right? So molar mass is going to be the one that allows you to convert from grams to mole. Okay. The reason why we need to do that, because the connection between molecule and grams is through mole, right? So in this case, you are going to start with 106 grams of ozone, right? So if you add 3 oxygen together, this is what the grams per mole would be, okay? And you are going to convert this by using the molar mass that we just calculated, okay? So grams would cancel out. Eventually, you're gonna get mole of ozone as the unit, okay? And the next thing, in order to find out the molecule, this is when you are going to use the Avogadro's number, right? Because we know that every 1 mole of something is equal to this many objects, right? So that means in this case, since we talk about molecule, how do I know this is molecule? Well, because it contains 2 or more atoms, right, within the chemical formula. So that's why we call this molecule. We don't call this atom, okay, so we call this molecule. So there are this many molecules of ozone in 1 mole of ozone. Okay, so you can, so that's why that's how you're gonna use the Avogadro's number. So if you cancel all the units, you are going to get these many molecules of ozone as the answer. Okay, my question is, what if I want to know how many atoms of oxygen are in this many molecule of ozone? What do I do? Okay, so that's going to be my follow-up question. This follow-up question is not on your lecture manual, but I want to jot it down because it's going to give you a little bit more understanding how can we connect from molecule to atoms and things like that. Okay, so pretty much if you're looking at this, right, so we know that this, if you're looking at this, you see that this is the molecule of O3, right? So from these grams. So what I'm going to start is, I'm going to start with what we know here. Okay, so from the previous calculation, we know that that many grams of ozone contain this many molecule of ozone. Okay, now I want to know only atom of oxygen. Okay, so this is molecule of ozone. Okay, it's not oxygen. Oxygen is just one single atom. So that means in this case, this is when you are going to use the mole to mole ratio, or in this case would be, you can do molecule to molecule ratio as well, right? So think about this, one molecule of O3. Okay, so one molecule of this contain how many atom of oxygen? How many atom of oxygen here? The answer is what? 3, right? So it's contain 3 atoms of oxygen, right? So one molecule of this contains 3 atoms of oxygen. That's what we know. Okay. Or you can find out mole to mole ratio as well, but you need to actually convert this to, so I'm going to show you 2 ways. Okay, so the first way is that we know, since we already at molecule, what I'm going to do next is just use the ratio that we know here, that every one molecule contains 3 atoms of oxygen. So what I need to do is just convert that, right? So one molecule of ozone, right? Because I want to cancel that, so it's going to be on the bottom. It's going to contain 3 atoms of oxygen, right? So if you calculate this, you are going to get 3.99 times 1024 atoms of oxygen in this molecule, right? Of course, it's going to be 3 times more because we are looking at each specific atom in here. Okay, so this is one way to do it. Another way that you can do this is through the mole concept. Okay, so you already have the molecule, right? So 1.33 times 10 to 23 molecules of O3. Okay, note that if you want to convert this into mole, you can do that as well by divide this by 6.022 times 1023 molecules, right, of O3, which is equal to 1 mole of O3. Okay. Now think about this. If you want to use mole to mole ratio, we know that this is also the mole to mole ratio, right? So every 1 mole of oxygen contain 3 mole of, every 1 mole of ozone contain 3 mole of oxygen. So that means the ratio of this can be written as 1 mole of ozone equal to 3 mole of oxygen, right? So that's the mole ratio. Okay, so similar to this, except this one we talk about mole. Okay, this one we talk about atoms and molecule. Okay, so it's one. So we talk about single atom, single molecule. This one we talk about Avogadro's number, right? So that's that many molecule. So note that in this case, what you are going to obtain is that the molecule of ozone will cancel out, mole of ozone will cancel out. You have more of oxygen left, but note that the mole of oxygen is not what we want. We want atoms, right? So that means the last step that you are going to take is going to convert mole of oxygen, okay, into atoms of oxygen by multiply back with the Avogadro's number. Okay, if you do this, you probably notice that the Avogadro's number here would cancel out anyway, so the ratio that you are multiplying still going to be the same of this ratio, right? So pretty much when we talk about mole to mole ratio or atoms to mole molecule ratio, we are talking about pretty much the same ratio. Okay, so except it's depend on like the number of objects that we are talking about here. So the final answer that you obtain from these 2 methods was still going to be identical. Okay, so it would be 3.99 times 10 to 24 atoms of oxygen. Okay, so either way is going to be the same. So this one is just require a longer route. This one is just require understanding, which is shorter. Okay. All right, so pretty much the lecture video cover the different type of mass, right? And we are also looking at how we can use those mass, right? Especially the molar mass to convert between grams to mole. And we also look at how we use the chemical formula ratio to help to convert from one species to another species. And we can use Avogadro's number to help to convert to atoms or molecule as well. Okay, so that's pretty much what we cover in this lecture video. Please start working on your homework soon. Okay, so this would be the homework that associated with this video.